Hello, calculus scholars. Today we're going to be doing skill 45B. So this is area between curves with a calculator. So you really will need a graphing calculator to do these problems, not because they're particularly difficult, but just because they have funky numbers with like decimals and stuff like that. And I really would like you to kind of get used to using the calculator as a tool once when you have set up the calculus problems. Now, the good news is today that all of this stuff can be done on the Desmos.com graphing calculator. We have no requirement to use the TI-84. So if you are kind of working in the real world and you need to compute an integral and see like how the numbers are working or need the service of a graphing calculator, that Desmos.com is a really nice graphing calculator. We would have you, kind of graph f of x and g of x and kind of analyze things like intercepts, where they intersect each other, where the x-intercepts are and stuff like that. So that's the next thing that you want to do. And you also want to be kind of thinking about setting up the integral as well. So we'll walk through a few delta math problems so you can kind of see the process. So we're going to start you pretty basic with a level 1. And these problems at initial glance do not look like, they're very difficult because they have, pretty nice straightforward functions and it's area between the curves. But what you will see is that the intersection points and the limits of integration are probably going to be, funky decimal numbers. So let's actually see what happens here. So g of x is equal to 2, and then the f of x is the parabola. So this looks like a type of situation where you're going to have the integral of g of x minus f of x dx. So that's kind of like, top minus bottom. And what we kind of just need to see is where are the limits of integration. And this is something that we can easily do on Desmos.com. So please go to Desmos.com. So I have that in a tab. And if you click immediately on graphing calculator, you can click on that. And I'm just going to write down our problem. So we have f of x equals to 3x squared. And then I have g of x, which will be on the blue line, is equal to 2. And the area that we want, I'm just going to kind of shade in it. We want this area of the graph. And you'll see why I kind of like to shade in a minute, just so we can see everything. And then our limits of integration, we can even just toggle our mouse over and we see that the lower and upper limits are negative 0.816 and positive 0.816. And I'll just make a note of that. So negative 0.816 and positive 0.816. All right. So then I'm going to click the enter button. And there is on the keyboard here, functions. And if you go to miscellaneous, there's actually an integral symbol. And it will even guide you to putting the limits of integration in. So I put negative 0.816. And put a positive 0.816 on top. And remember, this is g of x on top. So I'm just going to do 2 minus 3x squared. And if you click on the little thing on the left, it says integram must end with an integration variable like dx. So put parentheses around what you added or subtracted. And we get 2.177. So it says to the nearest thousandth on delta math. So we want 3 decimal places. So this rounds to 2.177. So then you're just going to enter that in. and we are good. One thing that I really do like is that you can actually interactively see the area accumulation. So as we kind of move right in X value, you can see that it actually starts showing the accumulation of the area. And we get to about 2.177, and that completes it. And I also really like how they think through the intersection points and conceptualize the integral as well. So all what you really have to do is just kind of conceptualize, top minus bottom, or we'll see like a more complicated situation on the next example. And I like to do things a little bit differently than the help videos on Delta Math with these. So I'm actually kind of guiding you through kind of some of these steps on your calculator. Delta Math has a fancier way with like variable storage, but I wanted to just kind of give you an introduction with your calculator. So I just kind of suggest entering your F, your G, and then kind of finding the key points and limits of integration. Okay. All right, here is example 2. So example 2 is a level 2 problem. And what we can see here is that we have actually 3 conditions. So we have f of x, g of x, and the line x equals 0. So our lower limit of integration is going to be, so I'm just going to kind of conceptualize this. So the top is our f of x. The bottom is our g of x. So this is the integral of 0 to maybe about 0.8 approximately of f of x minus g of x dx. So we could just think about this as top minus bottom. So the only reason why this is a level 2 is we're actually just kind of like putting in things like axes, or sometimes like x-intercepts as well, to give us kind of truncated regions of integration, or sometimes multiple regions of integration that we need to find. So let's actually go to our Desmos calculator and enter this in. So first thing first, I'm actually just going to clear and type in what we need. So f of x was negative 4x squared. And when you're putting the exponent, you can do the caret key, or there's actually an exponent in the menu as well. And then I have plus 3x plus 8. Here we go. And then the g of x is 2x plus 6. Try to get a nice picture here. I just moved the graph a little bit. And 0 is going to be our lower limit of integration. I don't know what my upper limit is going to be. What I do know, though, is that my top function is the quadratic. So I'm going to do negative 4x squared plus 3x plus 8. Put that in parentheses. And then I'm going to subtract the bottom function, which is 2x plus 6. So what's kind of going on geometrically here is we are wanting to find the area. I'll outline the area that we want to find. So Delta Math just wanted us to find this area. And then I just need to find that point of intersection and find that x value. So when I do that, I get 0.843. And just be sure that you put parentheses around what you are subtracting. And we get 1.243. And we're good. All right, let's look at a slightly more complicated type of thing. This is still a level 2, but it's a little bit higher end than the level 2 because we're kind of adding some regions of integration. So maybe I'll call this region 1, and then maybe I'll call this region 2. So for region 1, what we're doing is we're kind of doing the top and the bottom. So f of x is the curvy, and the straight line is g of x. And what we can kind of see in region 1 is that we are doing f of x minus g of x. And then in region 2, we are doing the integral of g of x minus f of x. And we do have to kind of keep in mind that limit of integration. So we start at 0, and we go to like kind of that intersection, and then intersection to like about 2.5. Let's actually go to Desmos and fire this up. So I'm just going to clear everything for right now, except for the names of the function. So the f of x would be negative x squared plus 1 or minus 1.5x plus 10. And then our g of x is negative 0.75x plus 6. And it is giving us the boundary of 2.5. Well, I'm going to put x equals 2.5. And we don't need to kind of worry about this step thing. But what we are kind of computing, so the first region that we are doing, I will just have in red. So we're looking at the red integral. Maybe I'll color this in as well. And then I need a blue region as well. So I'll just make a different color. I'll use blue. And in essence, what we are doing is we are just adding these regions together. Okay. So let's actually make the two integrals here. So the first integral, we're going to do the red one. I know for sure that our lower limit is 0. And then we're intersecting at 1.66. So then we ask ourselves, what's on top and what's on bottom? So on top is the f of x. I'm just going to put negative x squared minus 1.5x plus 10. Group that together. Minus a negative 0.75x plus 6. Now, This is not proper integral right now, so we need to make sure that we are putting in parentheses what we added and subtracted. And we can actually see that that piece of the area is 2.02. All right, so then we have to go. So then we're going from 1.66 to 2.5. So I'm going to create another integral. So I'm adding areas. So I'm just going to go to functions, integral. So I have 1.66, and then they gave an upper bound for our x value of 2.5. And what we can see is that g of x is now on top. So I'm going to do negative 0.75x plus 6 minus a negative x squared minus 1.5x plus 10. And I'm just going to put that in parentheses, put a dx. Ooh, rats. Ooh, we got to start again. Deleted it. So, woo, we got a little bit of a chutzpah here. So we got 0 to 1.66. And we're going to put on top the f of x. And I even like to, just group them in parentheses and not worry about the distribution. If you accidentally do like a subscript, then you can just do plus 6. Put parentheses around everything that you did. Put a dx at the end. I believe that was like 2 point. We went from 0 to 1.66. All right. Then what we're going to do, we're just going to add our next integral. I'm going to do the integral from 1.66 to 2.5. And I got on top the negative 0.75x plus 6 minus a negative x squared minus 1.5x plus 10. Put that all in parentheses and put a dx. I accidentally put a little dot there, so just move that out of the way. And I got 5.716. And we are good. So that is a harder version of a level 2.